Module 3, Lesson 7, Ordering Integers and Other Rational Numbers. So we have been working on getting numbers on the number line, and now we're going to work on putting them in order. Things least to greatest, greatest to least, things like that. Alright, we are going to write, interpret, and explain statements of order for rational numbers in the real world. We are going to show and explain that if A is less than B, then negative A is going to be greater than negative B because a number and its opposite are equal distance from zero. Things we've hit in prior lessons. And we're going to show and explain that moving along the horizontal number line to the right means the numbers are increasing. In class, we would play a game of guessing integer and guessing rational number. It doesn't really work very well in a video, so I'm going to skip those. So discussion. If we have two rational numbers that we want to graph and they are on the same number line, how would we describe to someone where each number lies in comparison to the other number? So I've got two numbers. Maybe we'll start with some nice easy rational numbers. Maybe I've got 5 and maybe I've got 4. How would I explain where each of these numbers would be on the number line? Not compared to 0, but compared to each other. That's the comparison we're making. Where are they on the number line compared to each other? Well, the lesser number is going to be left or to the left of the greater number. Or we can say that the greater number is going to be to the right or above the lesser number. Negative numbers are to the left of 0 and positive numbers are to the right or above 0. So looking back at my example with the 5 and 4 here, the greater number is going to be on the right hand side or to the right of the lesser number. 5 is greater than 4. So on my number line, I would say that my greater number is going to be to the right of my lesser number. Or I can say that my lesser number is going to be to the left of my greater number. Now that second part there with negative numbers, with negative 4 and negative 5, we would say that both of them are going to be to the left of 0, and we're going to say that the negative 5 is to the left of negative 4 because it's going to be farther from the 0 in the negative direction. So go ahead and describe the location on the number line of a number and its opposite. Go ahead and pick a number of your own choosing and describe the location on the number line of that number and its opposite. So for example, if I had 3 is 3 units to the right of 0, or above 0 if I've got a vertical number line. And I would say that its opposite which is negative 3 is 3 units to the left of 0. So 3 is 3 units to the right of 0, and its opposite, negative 3, is 3 units to the left of 0. So describe the location on the number line of a number and its opposite. Oh, we just did that one. Oh, sorry. So they're both the same distance from 0, but on opposite sides of 0. Alright, so if we were to list the numbers from least to greatest, which would be the farthest to the left on the number line, and why? And which would be to the farthest to the right on the number line? Well, we would say that the numbers on the number line decrease as you move to the left. So the smaller the number or the less the number, the farther to the left it goes. and they're increasing as we move to the right or as we go upward. So the number that is least would be the farthest left, and the number that is greatest would be the farthest right. So if I had 5, 2, and 7, this is the greatest number, so we would say it is farthest to the right. This is the least number, so it's farthest to the left, and this is in between the two. All right, so we're going to put this into some practical use here. We're going to graph the number 7 and its opposite on the number line, and then we're going to graph the number 5 and its opposite on the number line. So graphing the number 7, I start at 0, and I'm going, this is a positive 7, so I'm moving to the right to a positive 7. Now its opposite starts at 0 and goes in the other direction 7 units, and it would end up at negative 7. Now the other number we're supposed to graph is 5, so I will start at 0, and I will go 5 units to the right, because it's a positive 5, and then its opposite is to start at 0 and go 5 to the left. So where does 7 lie in relation to 5 on the number line? 7 is to the right. Of 5 on the number line. Where does the opposite of 7 lie on the number line in relation to the opposite of 5? So here is the opposite of 7, and here's the opposite of 5. And the opposite is negative 7. Negative 7 is to the left of negative 5. Negative 7 being the opposite of 7, and negative 5 being the opposite of 5. Now lots of students struggle with that. Lots of students think that negative 7 is greater than negative 5, but if we take a look at this number line, negative 7 is farther to the left, so it is less than negative 5. That's an important concept, something to try and wrap your brain around. So thinking of two numbers, the first number lies to the right of the second number. So I've got a number, and it is right of the second number. So what can I say about the location of their opposites? So if I have the opposite of the first number, how is that compared to the opposite of the second number? Well, if the first number is to the right, then their opposites are going to be reversed. It's going to be opposite. So the location of the opposites, the opposite of first is left, the opposite of right, of the second, opposite of the second. So when we have opposite numbers, we have opposite orders. So if the first number is to the right of the second number, if we look at the opposites, they will be in the opposite order. So the record low temperature for a town in Maine are negative 21 degrees Fahrenheit for January and negative 19 degrees Fahrenheit for February. Those are cold. So we're going to order the numbers from least to greatest, and we're going to explain how we came up with that order. Now these are negative numbers. I want to look at their opposites here for a second. The opposite of negative 20 would be 20, and the opposite of negative 19 is 19. And I'm looking at their opposites because positive numbers are numbers that students usually feel pretty comfortable with. If we look at the positive numbers, we would say that 20 is going to be to the right of the 19. It is greater than the 19. So I have these in order from least to greatest, 19 and 20. Now if I look at their opposites, and I remember that when we do order of opposites, that it's going to be the opposite order. Remember that from the last slide? The 20 was to the right of the 19, but if I do their opposites, then the 20, the negative 20, is going to be to the left of the negative 19. So looking at it on a number line, if 20 is to the right of 19, when I go over to the negative side here, it's going to be opposite. 20 is going to be, well, the opposite of 20, negative 20 is going to be to the left of negative 19. Another way to look at it is that these opposite numbers make pairs, but notice that the pair for the 19s is inside of the pairs for the 20. So we get that opposite order. So for each problem, we are going to order the rational numbers from least to greatest by first reading the problem, then drawing a number line, and finally explaining our answer. So we've got some steps we need to go through here. John's time for running the mile in gym class is 9 2/10 minutes, and Jackie's time is 9 1800 minutes. Who ran the mile in less time? So I've got a number line here. Now when I look at these numbers that I'm comparing, I notice that both of them are in 9 minutes. So I'm going to put a 0 here, but I'm not going to worry about putting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all that kind of stuff. I'm going to have 9 as my starting, and I'm going to put 10 out here because both of them are at 9 minutes. So not just are they at 9 minutes, they're both a little bit more. That's what that decimal means. We've got a little more than 9 minutes. So I'm going to take this space and I'm going to cut it into tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this one, 9 2/10 minutes, says that I'm right here. 9 2/10 minutes. Now when I look at Jackie's time, it doesn't have a full 2/10. It's got 1/10 and a little bit more, but not enough to get all the way to 2/10. So here is 9 1800. Now, if I'm thinking about answering the question here, who ran the mile in less time? Which of these two numbers represents less time? Well, this is 9 2/10. It represents a greater amount of time because it's farther to the right. So Jackie ran the mile faster. And I know that Jackie ran the mile faster because 9 1800 is to the left of 9 2/10 on the number line. And numbers that are less are left of numbers that are greater. So compared to each other, 9 1800 is less than 9 2/10. So exercise 3. For each problem, order the rational numbers from least to greatest, the least number to the greatest number. We're going to read the problem, draw a number line, and explain our answer. Mrs. Rodriguez is a teacher at Westbury Middle School. She gives bonus points on tests for outstanding written answers and deducts points for answers that are not written correctly. She uses rational numbers to represent the points. She wrote the following on students' papers. Student A was a -2. Student B was a -2 5/10. And the question is, who performed worse on the test? Okay, so I'm supposed to use a number line. And I'm going to put my 0 on here. Now I notice that both of these have a whole number of 2, so I'm going to put a 2 on my number line. Now I notice that this one, this -2 here, doesn't have anything that comes after it. So it lines right up here with the -2. So here's one of the students, student A. And then there's student B, who is at -2, and then they're halfway 5/10 of the way to -3. So I've got student A and I've got student B. And the question is, who performed worse? Who lost more points? Well, if we think of this, well, we don't really have to think of it too much. It's sitting here on the number line. This person lost only 2 points. This person lost 2.5 points. That's kind of icky. Would you like to be the person who lost 2 points, or would you like to be the person who lost 2.5 points? Who had more points taken away? Now, if we're thinking strictly in which number is greater and which one is less, we say that -2, that number is greater than -2.5. But we also need to think about the meanings of the numbers. When we talk about taking 2 points away, is that better or worse than taking 2.5 points away? Me personally, I would prefer to have no points taken away. I'd like to have a 0. That would be desirable. What does 0 mean in this problem? 0 means that no points were taken away. Student A only had 2 taken away, and student B had 2.5 taken away. So we could say that student B performed worse on the test because they had more points taken away. So a carp is swimming approximately 8 1/4 feet beneath the water surface, and a sunfish is swimming approximately 3.5 feet beneath the water surface. Which fish is swimming farther beneath the water surface? So I've got water, so I'm going to do a vertical number line here. And they're both below the water. I don't think fish really do much swimming above the water. I've got one of them that is 8 1/4, so I've got to come down here to 8 and a little bit more. So 8 1/4. And I've got another one that's 3.5 feet below. So 0 in this case is the surface of the water, and I'm asking who is farther beneath the water surface? Well, my second fish is only 3 and a little bit more, 3.5. So compared to 0, which one is farther below the water surface? Well, that would be the fish at 8 1/4 feet. So the carp is swimming farther beneath the water surface. All right, looking at example 2. Henry, Janan, and Clark are playing a card game. The object of the game is to finish with the most points. The scores at the end of the game are Henry at -7, Janan at 0, and Clark at -5. Who won the game? Who came in last place? And we're going to use a number line and explain how we arrived at our answer. Now it says who finished with the most points, the greatest amount of points. Well, I've got Janan at 0, and I've got Henry's at -7. 1, 2, 3, 4, 5, 6, 7. There's my -7. There's Henry. And I've got Clark who's at -5. Now looking at the number line, my numbers are lined up in order from least number of points to the greatest number of points. So 0 is actually the greatest number of points the way I have them lined up from least to greatest. So Janan actually won the game even though his points are 0. Who came in last place? Well, that would be Henry. He has the lowest number of points, the least number of points at -7. Clark is in between here with a -5. All right, looking at exercise 5. For each problem, we are going to order the numbers from least to greatest. We're going to read the problem, draw a number line, and explain our answer. Henry, Janan, and Clark are playing another round of the card game. Their scores this time are as follows. Clark at -1, Janan at -2, and Henry at -4. Who won and who came in last place? Well, let's make our number line here. going to drop a little 0 on here. And I've got Clark, who's hanging out at -1, and Janan, who is hanging out at -2, Clark, Janan. And I've got Henry, who's going to be at -4. So who has the greatest number of points? Remember, our number line is in order from least to greatest. So the greatest number of points is going to go with Clark. Yay, Clark, good job. Last place is Henry. Henry's down here at -4. He's got the least amount of points. Same instructions, going to go least to greatest. So we've got elevations using rational number. We're going to order the numbers from least to greatest. I've got Cayuga Lake, Mount Marcy, and the New York Stock Exchange Vault. So this is sea level, so I'm going to do a vertical number line here. And I've got some below sea levels, and I've got 2 above, so I'm going to put 0 here and give myself some room to work. Cayuga Lake is 122 meters above sea level. The Stock Exchange is 15 and 24 meters below sea level, so that's going to be a negative 15 and 24. Now the question is, where does Mount Marcy go? Does Mount Marcy fit in this space here, or is it Mount Marcy in this space here? Well, 1,629 above sea level is going to be farther above sea level. It's going to be way farther up here. So if we're putting them in order from least to greatest, well, our least is the -15 and 24. That's below sea level. And then we've got Mount Cayuga at 122. And then we've got Mount Marcy at 1,629. And these are all measured in meters. So here I have them represented as rational numbers, and here I have them in order from least to greatest. All right, so in class we have a little activity we would do with this. But it's not an activity that really works very well with online. But I will try and read it to you. So it says the first number is 3 units to the right of -1. So find the -1 and go 3 units to the right. The second number is 5 units to the left of 4. What is the value of each number and which is greater? So the first number is 3 units to the right of -1. The second number is 5 units to the left of 4. What is the value of each number and which is greater? So the first one is 3 units to the right of -1. So here's -1, 1, 2, 3. So my first number is 2. The second number is 5 to the left of 4. So I've got 4, and I'm going 1, 2, 3, 4, 5 to the left of 4. So my second number is going to be -1. Then we are supposed to say what is the value of each number, 2 and -1, and we would say that 2 is greater than 1. All right, so taking a quick look at the I can statements here. Hopefully you're feeling like you can write, interpret, and explain statements of order for rational numbers in the real world. The explain part is really super duper important. Can you explain why you put this number as greater or less than another number? Show and explain that if A is less than B, then -A is greater than -B. And we really drilled into that looking at the number lines, because a number and its opposite are equal distances from 0. I can show and explain that moving along the horizontal number line to the right means the numbers are increasing. We looked at a whole bunch of examples. The farther to the right you go, or the farther up you go on the number line, the greater the numbers are. So that concludes Module 3, Lesson 7. Make sure that you complete your exit ticket. Make sure you do your problem set. If you've got questions, make sure that you contact your teacher.